In our previous lecture, we learned about linear equations and the slope of a line. So this lecture will be about applications of linear equations. So we're going to see how we can use what we learned previously to solve a variety of problems. The first example asks us to order the following graphs, which you can see on your screen, by increasing slope of the line being displayed. So we want to order these. We're going to put A, B, C, D in order based on the increasing order of the slopes of the lines. Now we know from our last lecture that A and D are the graphs of lines with positive slope. We know they have positive slope because as we move from left to right, the graph is clearly increasing. On the other hand, B and C are decreasing as we move from left to right. So these are graphs of lines with negative slope. So B and C have negative slope, A and D have positive slope. So we already know that in terms of ordering them, A and D are going to have larger slope than B and C. There's one other factor that we can consider here, which is that the steepness of the line is related to how large the slope is. So if we compare graphs A and graph D, graph A is clearly steeper. It's increasing faster, so it has a larger positive slope than graph D. Otherwise, if you look at B and C, C is decreasing faster. It has a steeper line, steeper slope, so C is more negative than B. So I'm going to say C should be the smallest because it's the most negative, then B because it also has negative slope, then D has positive slope but it's less steep, so smaller positive slope, and A should have the largest slope because it's positive slope and it's the higher number, the steeper line. Now if we weren't sure, just from looking at them, we could always try to pick out a couple of points and maybe calculate these slopes to compare them. So these may not be exactly on the lines, but I'm just picking points that are pretty close to get some idea. So let's say for graph A, I've picked these 2 points. I think it looks like 0, 0, the origin, and then maybe 3, 6, because each little hash mark on the axis is 3 units. Then if I calculated that slope, I would have 6 minus 0 over 3 minus 0, which is 2. For graph B, the points look like 0, negative 3, and negative 6, positive 6. So if I calculate its slope, I get 6 plus 3 is 9 over negative 6. That's negative 3 over 2. For graph C, the points are 0, 0, and 3, negative 6. So I'll calculate its slope. I get negative 6 over 3. That's negative 2. And for graph D, the points are 0, 0, and 6, 3. So when I calculate its slope, I get 3 minus 0 over 6 minus 0, 1/2. Now, if I place those in order, the most negative, the smallest one, is negative 2, then negative 3 over 2, then 1/2 is smaller than 2, and 2 is the largest. And that's exactly what we were able to observe just by looking at it. C had the most negative slope, so it's got the smallest slope. B has negative slope, but it's not as steep as the slope in C. D has positive slope, but it's not as steep as the slope in graph A. And A has the largest slope because it's positive and steep. Okay, let's see another question. This question asks us to find the equation of the perpendicular bisector of the line segment joining the points 7, 5 and 13, negative 1. And we're asked to write the equation in the form y equals mx plus b, which we know is our slope-intercept equation, and then identify m, which will be the slope, and b, which will be the intercept. So that's kind of a lot to take in. Let's just go step by step. So first of all, it says we're looking for a perpendicular bisector of the line segment joining the points. So let's start by plotting the points and drawing the line segment that connects them. So this is just a rough sketch. I'm not at all trying to be accurate, but I just want to get an idea of what picture I'm talking about. So let's say this might be roughly 13, -1, 7, 5, and the line segment connecting them. And that, of course, should be a straight line, but I'm drawing it by hand, so it's not looking perfectly straight, but that should be a straight line. Okay, so that's the line segment. We want to draw a perpendicular bisector. What does that mean? Well, the word bisect, that suggests that we want to cut this line in half. And perpendicular means we're looking for the line that crosses it at a 90-degree angle. So what it's asking for is the perpendicular line passing through a specific point. Which specific point? Well, it should be the midpoint of this line segment. So our midpoint formula is we take the average of the x-coordinates, that's x1 plus x2 divided by 2, and we take the average of the y-coordinates, that's y1 plus y2 divided by 2, and these become the x and y coordinates for our midpoint. So let's first find our midpoint. So with the points that we are given, 7, 5, and 13, -1, that's going to be 7 plus 13 over 2, so 20 over 2, that's 10. And -5 minus 1 divided by 2, so that's 4 divided by 2, so that's 10, 2. So this midpoint of the red line segment is 10, 2. And now what the question is asking me for is the perpendicular line that passes through the point 10, 2, perpendicular to the red line segment. So what else do we need to know about the red line segment? Well, we need to know its slope. So let's find the slope of the red line segment, because we know that the slope of the perpendicular bisector is going to be the negative reciprocal of the slope of the red line segment. So I can use the points I'm given. I'll do -1 minus 5 over 13 minus 7. So that's -6 over 6, which is -1. So if the slope of the red line segment is -1, then the slope of the perpendicular bisector, which I drew in green, is the negative reciprocal of -1. And that is 1. Make that look more like a 1. So the slope of the green line should be 1 because I changed the sign from negative to positive and I flipped it over, but since -1's reciprocal is -1, then when I make it positive, it's just 1. So I'm looking for a line with slope 1 that passes through the midpoint 10, 2. And I know that I can just write the point slope equation of the line, and that will be, so I can use either point that I want. Let's go ahead and use 13, -1. So it will be y minus -1, and that's equal to, the slope is 1, then we'll have x minus 13. So the question asked for the slope-intercept form. That means I'm going to need to solve for y. So I have y plus 1 equals x minus 13. I subtract 1 from both sides, so I get y is equal to, oh, and I'm sorry, I'm using the wrong point. So I should use 10 and 2. That's my fault. So y minus 2 is equal to x minus 10. Then I'll add 2 to both sides and get y equals x minus 8. So in this case, I needed to use the point 10, 2 because that's the only one that lies on the green line, and the green line's the one I'm finding the equation for. So finally, to answer the question, it asked me to identify m and b. So the slope m is equal to 1, and the intercept b is -8. And those are coming directly from the slope-intercept form of the line that I found. All right. The next question says, the Topology Taxi Company charges $1.90 for the first quarter of a mile and 35 cents for each additional 1/5 of a mile. So we write that down. $1.90 for the first 1/4 mile and 35 cents each additional 1/5 of a mile. And the question asks us to write a function, capital F, to model the number of miles driven and the cost of the taxi cab fare. We're going to use little m for miles. So I just want to point out here, let's not get confused because we've been using little m for slope, but in the context of this problem, little m is just the independent variable, so it's just like x, and capital F is going to be our dependent variable, so it's just like y. Okay, so how can we use the information given to write f as a function of m? Well, I know that for each additional mile, I pay, for each additional 1/5 of a mile, I pay 35 cents. So I want to multiply by 5, so 5 times 35 cents is how much I pay for each additional 1 mile. So I just multiplied the cost of 1/5 mile times 5 to find out the cost of each additional mile. That's 5 times 30 cents is $1.50, and 5 times 5 cents is 25, so that's $1.75 each additional mile. Okay, and then we kind of have two situations here. So it depends if we're going less than 1/4 of a mile or more than 1/4 of a mile. And of course, in real life, if we were going less than 1/4 of a mile, we probably wouldn't call a cab. But let's go ahead and just consider the two situations. So I'm going to write this as a piecewise defined function. I'll pay $1.90 if my trip is less than or equal to 1/4 of a mile. And remember, I'm using m as my independent variable. If my trip is greater than 1/4 of a mile, then what am I going to pay? Well, I'm going to pay $1.90 plus $1.75 for each additional mile. So I don't want to write 175 times m. That's close, but that's not exactly right, because I need to take into account the fact that I already paid for the first 1/4 of a mile. So I need to say m minus 1/4. That should give me the number of additional miles. So m is the total number of miles for my trip. If I subtract the 1/4 mile that I already paid for, then it gives me the number of additional miles. And I'm paying $1.75 per additional mile. So that should be, let me write 175 times m minus 1/4, then plus 190. So that should all go on one line, but I couldn't quite fit it. So the function f is a piecewise defined linear function. If the trip is less than or equal to 1/4 mile, then we just pay a flat fee of $1.90. Once we cross over a quarter of a mile, then we pay $1.75 per mile. So we just had to make this little adjustment of m minus 1/4 to represent the additional miles. Okay, next we have the equation y equals 8.41t plus 218.5 represents the change in the college faculty salary index for a particular college where 2003 is the base year, 0, and t is the number of years since 2003. So that's important. 2003 is the year 0, and t is the number of years since. And this is a function y of t. It asks us to use the equation to predict when the index for faculty salaries will be 300. So as soon as I see these words predict when, I know that I'm going to solve for some value of t. Okay, so let's use the equation that we were given. And since the equation tells us about the salaries, I'm going to replace y by 300 because that's the target I'm looking for, and then I'm going to solve for which value of t corresponds to that y. And then I just have to remember, in the end, this t is actually years since 2003, so I'll have to take that into account. But let's start here with 300. I'm going to subtract 218.5 from both sides, which is going to leave me with 81.5. Then, so 81.5 is equal to 8.41t. And then I'll divide by 8.41 to get t by itself. And if I plug that into a calculator, 81.5 divided by 8.41, that's t. And that's approximately 9.6908. I'm going to chop it off at 4 decimal places. And then this is the number of years since 2003. So 9.69 years after 2003. So I'll round up to 10 years and say that sometime in the year 2013, the index for faculty salaries will be 300, or was 300 since that's in the past. According to the model, in 2013 we should have hit the mark 300. Okay, so we're told the graph shows the increase in the civilian labor force of a particular country from 2003 to 2006. So you can see here on my x-axis I have 2003, 2004, 2005, 2006. And then I have the corresponding values in millions of civilian labor force. So 151 million members of the civilian labor force in 2003, going up to 156.3 million members of the labor force in 2006. That's how I'm reading this graph. And the question says, assume that the rate of increase continues for the next several years and can be modeled by a linear equation of the form L equals mt plus b. This is just our familiar slope-intercept form. So it's going to ask us several questions. The first question is, what is the average yearly increase from 2003 to 2006? So in 2003, I have 151 million. I'm actually going to write 0 instead of writing 2003, because again, I'm thinking of it as years since 2003. And then for 2006, since that was 3 years after 2003, I'm going to write 3, 156.3. So those are these 2 points. I've written their ordered pairs, and it asks me to find the average yearly increase, and it gives me the hint that that's just the linear slope from 2003 to 2006. So let's calculate that. Using these 2 points, the slope should be 156.3 minus 151 over 3 minus 0. That's 5.3 over 3. And rather than write 5.3 over 3, I'd like to think of this as 1/3 times 53 over 10. 5.3 is 53 over 10, so I get to say this is 53 over 30. We could have left it as 5.3 over 3. I just think 53 over 30 looks nicer. It's a little weird to have a decimal inside of a fraction. Okay, part B says, use the result from part A as the slope of the linear model and the point that represents the 2003 data. So that point was 0 and 151. And our slope is 53 over 30. Use that to write an equation that describes the increase in the labor force. Let T be the number of years since 2003. Okay, so I'm going to write the point slope equation. So I'm going to use L and T as my variables. So I get to say L minus 151 is equal to 53 over 30, since that's my slope, times T minus 0. I can add 151 to both sides, and I can say L is equal to 53 over 30 times T plus 151. And that's a linear model. We did the point slope form and the slope intercept form. So then it says, use the equation from part C to predict the size of the labor force in 2011. Well, first of all, let's note that 2011 is 8 years after 2003. So I want to plug in T equals 8 to my equation. So I have 53 over 30 times 8 plus 151. That should be equal to L. And I'll just simplify. So 8 times 50 is 400, 8 times 3 is 24, so this is 424 over 30 plus 151. I can plug that into a calculator to simplify. 424 over 30 is 14.1333, and then when I add 151, that should be 165.1333. So that's approximately the numbers of millions in the labor force we would have expected in 2011. Finally, it asks us to use the equation from part B to estimate in what year the labor force will reach 202. So it's very similar to the problem we did before. When we see what year, we're going to say, okay, I'm solving for T. And that's going to give me an answer in the number of years since 2003, so then I'm just going to add it to 2003 to find the year in which it would happen. So we said 202 equal to our equation. Our equation was 53 over 30 times T plus 151. I'm going to find the value of T. So I subtract 151 from both sides. I get 51 is equal to 53 over 30T. Then I'll multiply on both sides by 30 over 53, because I know if I do that on the right side, that will cancel with the 53 over 30. So I get whatever is 30 over 53 times 51. That will be my T. And as usual, I can simplify that using a calculator. And it's going to give me T is approximately 28.8679. So in terms of years after 2003, I'm going to say around 29 years. So the labor force will reach 202 million about 29 years after 2003. And that should be the year 2032. I just added 29 to 2003. Okay, here's another type of question we can solve. Two cars are 500 miles apart. So here's a car, here's a car. This distance is 500 miles. And it says that they're moving directly toward each other. One car is moving at a speed of 100 miles per hour. So one car, 100 miles per hour, and the other car is moving at a speed of 70 miles per hour. So the other car, 70 miles per hour. And it asks us, assuming that they start moving at exactly the same instant, how long will it take for them to meet? Okay, so again, how long? We're going to be solving for a time. So we want to think about what is the total distance that these cars are traveling. That should be 100 miles per hour plus 70 miles per hour because they're moving toward each other per hour. Okay, so 100 miles per hour plus 70 miles per hour is how much distance is being covered each hour. And they're 500 miles apart. So we're going to say 500 miles is equal to 170 miles per hour. So I could use h for hour, or I could use x for hours. It doesn't matter. But to solve for h or x, I'm going to divide by 170, and I'm going to say 500 over 170 is equal to h. And 500 over 170, well, that's just 50 over 17. And so 50 over 17 should be almost 3 hours. 2.9412 hours if we round to 4 decimal places. Okay, so that answers that question. Okay, now we have, based on past experience, a company knows that charging $600 for a seminar on management techniques will attract 1,000 people. For each $20 decrease, 100 additional people attend the seminar. So this question asks us to find a price function and a quantity function based on n, the number of times they decrease the seminar fee, and then find the revenue function. Okay, so the key here is that we want the function to be a function of n, the number of times they decrease the fee. So let's think about this a little bit. So let's think about quantity. If we charge $600, that means we didn't decrease the fee at all. So I'm going to say no decrease in fees, 0. Then we know that we have 1,000 people coming to our event. If we decrease by $20, so that's one time that we're decreasing, one increment of decrease, then we get 1,100 people to come because 100 more. Again, if I decrease another $20, so a second increment of decrease, then I'll get another 100 people to come, so 1,200. So I could keep going like this. So I'm going to put ... So if I wanted to express this idea of quantity of people attending the event in terms of the number of decreases, I could just find a linear equation using these points. So I could find the slope, and that should be 1100 minus 1000 divided by 1 minus 0. That's just slope of 100. And then I could find the point slope form of the equation. So I'm going to use Q for quantity. Q minus 0 is equal to the slope times N minus, and I'm sorry, that's Q minus 1000 and N minus 0. Q minus 1000 is equal to 100 times N minus 0. So if I solve for Q, I would get that quantity Q is equal to 100N plus 1000. And that makes sense if we think about what the problem told us. It said that every time I decrease the fee, that's represented by N, I add 100 people. So I start with 1000, and then every decrease gives me 100 more. So it's very intuitive. Let's do the same thing for price. If I was thinking about the price, I would say, well, my initial price is 600. So that represents, again, I want the independent variable to be the number of times we decreased the fee. So if I didn't decrease the fee, I decreased it by 0 times, then my price is 600. If I decreased it once, then I subtracted $20, so it's 580. If I decreased it twice, then it's 560. And again, I'm going to put dot, dot, dot because I could keep going this way. So if I wanted to find the linear equation for price, I again can use any 2 points. So let's say I do 580 minus 600 over 1 minus 0. That's negative 20. No surprise, because I'm subtracting $20, so negative 20 makes sense. And then I would say, instead of Q, now I'm using P for price. P minus 600 is equal to minus 20 times N minus 0. So that gives me P is equal to minus 20N plus 600. And again, it's very intuitive here because I started with 600, that's this intercept, and every time I decrease the price, I subtract $20. So negative 20N plus 600 makes perfect sense. Now, finally, the question has asked us to then find the revenue in terms of N. So we need one more piece of information here, which is what is revenue and how is it related to quantity and price? So revenue is just the total amount of money that we're taking in if we're selling something like tickets to a seminar or widgets or cookies or pitchers of lemonade. If we're selling something, then the revenue is the total amount that we're taking in before we subtract any costs for materials or paying our employees or utilities, right? So revenue is just the quantity of items that we sold times the price at which we sold them. This is in general for any business model situation. So in our case, the quantity of people attending our seminar versus the price that we charge them to attend the seminar. And it asks us to find revenue as a function of N. So this is quantity times price is equal to revenue. So I'm going to say R is equal to Q times P. And I'm going to put these functions that we found. So R is equal to, for Q we had 100N plus 1000. And for P, we had minus 20N plus 600. Now, if we want to, we can actually multiply this out and simplify our answer. So we'll have 100N times minus 20N. That should be minus 2000N squared. Then we have 1,000 times minus 20n, so that's minus 20,000n. And we have 100 times 600n, so plus 60,000n, and plus 1,000 times 600, so that's plus 600,000. So we could say that revenue is minus 2,000 n squared. If I combine 60,000 n minus 20,000 n, that's plus 40,000 times n, and plus 600,000. Okay, perfect. Okay, next, we want to find a linear cost function if the fixed cost of producing some items is $400 and the total cost of producing 60 items is $2,200. So what this says is that in order to produce whatever it is we want to produce, again, it could be pitchers of lemonade or widgets or cookies, our initial startup costs are $400. We're going to pay that no matter how many we make. So I'm going to think of that as an ordered pair, 0, 400. And what that ordered pair represents is that before I even start making anything, I'm paying $400. Then we know that the total cost for producing 60 items is $2,200. So I'm going to think of that as the ordered pair 60, 2,200. And because it says total cost, I know that my startup cost is included in there. So I don't have to add it because it's already in the total. And we want to find a linear cost function, so we know what to do. Let's find the slope. So the slope is going to be 2,200 minus 400 over 60 minus 0. That's 1,800 over 60, which is 180 over 6. So that's 30. So the slope is going to be 30. And then we can find the point slope equation by using either of the 2 points. I would prefer to use the point with the 0 in it to simplify my work. So I'm going to say the point slope equation. Let's use C for cost. So cost minus 400 is equal to 30 times x minus 0. So cost is equal to 30x plus 400. And that's our linear cost function. Okay. The last question in the lecture note is about the cost of a snow removal service for residential driveways is $60 per season plus $40 for each time the snow is removed. So you pay a $60 flat fee just to have the snow removal service, and we don't know how many times it's going to snow every winter, so they're just going to charge us $40 to come out each time it snows. The question asks us to write a linear equation that gives the cost y in terms of the number of times the snow is removed. So x is going to be the number of times the snow is removed for one winter, or one season. Okay, so that should be y equals $60 plus $40 every time the snow is removed. If we weren't sure, we could, again, think about ordered pairs. We could think, well, even if they didn't remove any snow, I'm paying them $60, then every time they come out, I'm paying them another $40. So if they come plow my driveway once, then I'm paying them $60 plus $40, that's $100. If it snows twice and they have to come twice, then I'm paying them 60 plus 40 plus 40, that's $140, and so on. So I could keep going like this. And then I could find the slope of the line. I could say 140 minus 100 over 2 minus 1 is 40. And then I could plug in any of these points. So I could say y minus 100 is equal to 40 times x minus 1. So y minus 100 is equal to 40x minus 40. Add 100 to both sides, and I'm going to get exactly y equals 40x plus 60. So this is exactly what it is, but kind of just by thinking about it in regular everyday terms, we could write this equation down without even going through the process. However, if it helps you to think about the ordered pairs and go through this process, that's perfectly great as well. Next, we're asked to use the equation that we found to find the cost after the snow has been removed 6 times. So I'm just going to plug x equals 6 into my equation, because that would mean it snowed 6 times and the snowplow had to come plow our driveway 6 times. So y equals 60 plus 40 times 6. That's 60 plus 240, that's 300. And what does this represent? That's $300 that we're going to pay. So the cost is $300 after snow has been removed 6 times. All right. Finally, it says if the cost is $300, then how many times was the snow removed? So now we can replace y by 300 and solve for x, because x is how many times. So I know I want to solve for x. So I have 300 is equal to 60 plus 40x. Subtract 60 from both sides, I get 240 is equal to 40x. And divide by 40, so I get 6 is equal to x. So if the cost is $300, then snow was removed 6 times. So if we compare, that's exactly what we already knew, because we already found in part B that when snow is removed 6 times, we paid $300. So this question could be asked in 2 different ways. It could be they give you the cost and they ask you to find the x, or they give you the x and they ask you to find the cost. That is the final question on this lecture note of applications of linear functions. So I'll go ahead and stop the recording here, and in our next lecture video, we'll learn a little bit about linear inequalities.